So I have been asked to deliver a talk on geotechnical schemes for disaster risk reduction. So this is the content of my today's presentation. I'll be briefly talking about some of the definitions, sustainable development goals, disaster risk reduction and its background. Then some compilation on earth as a sustainable construction material with the risk resilience. Then water security. I will cover water security, also geohazards including landslides. Then some of the solutions involving geosynthetics, geonaturals, natural geocells, and some of the applications and reinforcement mechanisms. And I will also present some model studies, experimental studies that we have taken up in the laboratories as well as in the field, and some of the case studies that I have undertaken as part of consultancy services. So what is sustainability? As the term says, it is the ability to sustain or ability to continue at the same level of performance for a period of time. That is sustainability. So these days, we hear a lot about sustainability. Actually, it is the ability to sustain at the same level of performance. And what is infrastructure? It's the basic systems or services that a society needs for efficient progress or day-to-day working. So we have, for example, wherever you are sitting, you have basic infrastructure. You have the computer, a mic or earphone, so that you are able to hear it properly, or the speaker. And I am sitting in my office room. So in all this, any system or service which make our life comfortable is can be called as infrastructure. And mostly we refer infrastructure to, say, buildings or transportation network like roads, railways, etc., etc., and also power supply. All that actually includes everything. And climate change. What is climate change? This is another term that we often hear. It is the change in Earth's weather. Basically, it is getting warmer. The world is getting warmer. We hear about global warming. Now it is global heating. And as a result of human activity, increasing the level of carbon dioxide in the atmosphere. So these days we talk about carbon footprint, the emission of CO2. Wherever we can reduce the CO2 emission, then we say that is a sustainable approach. And this climate change impact is very huge. Basically, our rainfall distribution has become erratic. There are supporting studies available which says due to climate change impacts, rainfall distribution has become erratic, leading to floods in the rainy season and droughts in the summer. Our average annual precipitation remains the same, but the number of rainy days has decreased. What does it mean? The intensity has increased, that leads to floods and droughts because groundwater is not recharged. Then wildfires, heat, erratic rainfall distribution, water scarcity, landslide, and also earthquakes. And we all know about the 17 Sustainable Development Goals envisaged by the United Nations, targeted to be achieved by the year 2030. It's already 2025, 5 more years to go. We don't know whether we will be successful, but the effort must be on. Especially SDG 6 talks about clean water and sanitation. SDG 9, industry, innovation and infrastructure. SDG 11, sustainable cities and communities. These 3 SDGs, SDG 6, 9 and 11, we civil engineers have a direct contribution to make. And we have contribution to make in all SDGs indirectly. But especially 6, 9 and 11. It is completely in our hands. Actually, my research area also revolve around these SDGs, SDG 6, 9 and 11. I work on disaster risk reduction, basically earthquakes and landslides. And I also work on water geotechnics, water security, and also coastal reservoirs, then bank protection, and sustainable infrastructure for slope stabilization, landslide mitigation, etc. This is a picture from my hometown, my village in Kasaragod district, in the interior village. You can see it's very green. I have put this picture because this is one place I know where water table has not gone down even by an inch. I have visited several areas as part of water mission studies, including Jammu and Kashmir, Andhra Pradesh. I have seen due to over exploitation or extraction of groundwater, water table has gone too down. Here we have a lot of open wells and open water lakes. So water table has not gone down because we are storing water. And in my today's talk, I will be taking some abstracts from my recently published book, Civil Engineering for Disaster Risk Reduction. It published by Springer. Then Civil Engineering Innovations for Sustainable Communities with Net Zero Targets, published by CRC Press, Taylor and Francis, London, UK. And it is co-edited with Professor Vinod Chandra Menon. He was the founder of National Disaster Management Authority in India. We know about the National Disaster Management Act, NDMA. It was enacted in the year 2005. So Professor Menon was Chief of Emergency at the United Nations. Prime Minister Manmohan Singh invited him to found National Disaster Management Authority. Now we have NDMA with the very well structured KSDMAs in every state, SDMAs in every state, State Disaster Management Authority. In Kerala, we have Kerala Disaster Management Authority. Karnataka, we have Karnataka Disaster Management, like the Tamil Nadu, we have Tamil Nadu Disaster Management Authority, like that. And also every district also have DDMAs, District Disaster Management Authority, led by the district commissioner or the district collector. So Professor Menon was the founder of NDMA. So we, authored a book recently. So I will be presenting some extracts from that also. And another book authored with Professor T.G. Sitaram, the current chairman of ASAP, on geocells. So I will be taking some extracts from these books and presenting to you today. And we know about different natural hazards like earthquakes, floods, landslide, tsunami, and man-made hazards like war, accident, fire, especially this. Is there any problem? Is my voice audible and the slides are moving?
Yes, sir, it is fine.
Thank you. Yeah. Actually, this war or accidents, they are all man-made, no? And if we look at the disasters arriving out of these hazards, floods contributes maximum to the economic loss, followed by drought, cyclone, earthquake, landslide. And it's a wrong terminology to use the term natural disaster. Actually, they are natural hazard. They become disaster due to our own exposure and vulnerability. So there is a popular saying, declaration by the United Nations, Chengdu Declaration of Action. It says there is no such thing as natural disasters. Natural hazard become disasters as a result of human and societal vulnerability and exposure. And it can be addressed by DC policies. Disaster risk reduction is a no-regret investment that protects life, property, livelihoods, schools, business, and employment. This is very, very actually to the point. Normally, when we say provide a shear band to make a structure seismically resilient, people say why shear band, it will cost additional 8% for that small cost saving. So we are seeing Latur when the earthquake hit in 1993, early morning, we lost close to 10,000 people. But next year, same time, early morning, California also hit an earthquake. The casualty was just 2. It's all because we are not prepared. We were having fragile houses, not designed to withstand the earthquake forces. And similarly, we spend a lot on our housewarming function, lakhs of rupees. But for soil investigation, it may be around 20,000 rupees. We hesitate to do. Actually, soil investigation, geotechnical investigation must be part of, because the entire structure we are investing lakhs of crores of rupees, and the structure has to be found on earth. So geotechnical investigation, it doesn't cost anything actually. It should be a practice to carry out geotechnical investigation. That is a disaster risk reduction is a no regret investment. And there are 4 elements of risk: hazard, exposure, vulnerability, and location. Again, United Nations says risk is contributed by these 4 elements. If we can take care of any one of these, entire risk can be eliminated completely. Hazard, it may be earthquake, flood, whatever it is. The location, wherever we are, so very less choice we have. Then exposure and vulnerability, it is completely on our hands. Actually, I was part of the Wayanad landslide team. I have seen 200 buildings completely washed there with no remains. And most of the buildings were either in the floodplains, and there were some building, including one resort in the stream bed itself. So we made them exposed. It was a natural hazard. It became disaster because of the exposure only. So when we have infrastructure development, houses comes, building comes, chimney comes, water tank comes, high-rise buildings, bridges, and everything has to be founded on earth. If an earthquake happens in Greenland, say Greenland is a place where there are no people, no, it is completely covered with ice. Whereas Iceland is a place which is very green. So if an earthquake happens in Greenland where there are no buildings, no casualty, no problem. So we usually say earthquakes don't kill people, but buildings do. So when we have all these structures and earthquake happens, if the structures are not designed to withstand the earthquake forces, then it can collapse. Finally, ultimately, everything has to be supported on earth. So let us see soil as a sustainable construction material. I will pass some slides. Some of the cave temples, completely made of rock. Badami cave temples, Ellora caves. This is a wonder actually. Normally we construct from bottom to top. This is carved out of a single stone from top to bottom. And Kallanai Dam, built by Chola King Karigalan, 1st century AD, world's 4th oldest dam, which is still in use. Grand Anicut. Kallanai means it is made of kall, stones. Global Vipassana Pagoda. I am a consultant to them. Actually, this is completely masonry structure, largest masonry dome structure in the world. It's in Mumbai. They didn't use RCC or steel because it is designed to stay for 2000 years. Sustainable approach with the masonry stones interlocked and also limestone as mortar. The Ayodhya temple again built on stone, built by using stones. There are other structures also using stones and mud. And we have different types of earth buildings, rammed earth. It can give a very good cozy look also. These are some of the rammed earth buildings. Wetland oak structure, which is again has disaster resilient properties as well. Poured earth. So Laurie Baker, actually he was a UK citizen. He was awarded with the 4th highest civilian award in the country, Padma Shri. He settled in Thiruvananthapuram, Kerala, and he promoted construction out of mud. Because of these advantages, low material cost, interior temperature regulation. Now we are feeling the heat now. If you are in concrete buildings, in the night you see it emits the heat absorbed during the daytime and we feel a lot of heat. But melt buildings, and it also gives a good beauty and good flexibility, simple to build, strong, long lasting. My ancestral home was 300 years old. It was just a mud construction. We had great difficulty in demolishing that now because it was very old, no. So when a new home was to be constructed, walls were so strong actually and long lasting. 300 years it stood. So Laurie Baker says you cannot get more sustainable or renewable resource than mud. Traditional bhungas in Kutch region, Assam type houses, these were all actually earthquake resistant. Banal architecture of Uttarakhand, Dhajji Devari buildings in Kashmir. 2001 Kashmir earthquake took away close to 1 lakh people alive, and some of the Dhajji Devari buildings sustained earthquake shocks. Here you can see after Latur earthquake, picture 1, you can see a out-of-plane collapse of a school building wall, and in the second picture you can see because of the timber inclusion that wall is saved. Simple reinforcement. I will give you another example from Turkey. Here you can see on the right side there is a modern RCC building and left side is a masonry building with the timber inclusion. After 99 Turkey earthquake, the modern RCC building collapsed completely, but the masonry structure is stable. See, And we have Ramappa and Thousand Pillar temples where they use an ancient vibration isolation technique using sandbox. It's a mixture of lime, jaggery, karakaya, and it acts as a cushion. And they absorb the vibrations. We know about this leaning tower of Pisa. It is leaning because of the differential settlement. And when they were erecting, they did not make it completely vertical. They maintained the lean so that maintain the tilt so that it becomes unique and attracts tourists, and now it's a major source of economy, and it is regarded as a wonder, but actually it was a blunder. It was not designed properly. That is why it leaned. Again, Ratneshwar Mahadev temple in Varanasi also leaning. If same phenomenon of differential settlement happens to our house, it does not become a wonder or tourist attraction, but it becomes a disaster because cracks will develop. Yeah, 2 days back I went to one site. There is a road, and on top of that they have a good site, very good site, and they wanted to build a two-floor building, so a small house only, individual house. But when they made the excavation to place the foundation, they found after 2 meter depth, it's a very soft soil. On top of the 2 meter is a hard laterite soil. After that, it's a very soft soil. Actually, it was a paddy field filled with soil, filled up soil. And if they place their footing on that soil, definitely, if it is with the isolated footing, different settlement is going to happen, and cracks is going to build up. That is why then they called us for the geotechnical investigation. We collect the soil sample and we suggested, recommended some ground improvement. So geotechnical investigation is very important even for a small individual house. So if we don't take care of the design to be disaster resilient, these things of collapse can happen. Here is a best example how an engineering intervention can mitigate the disaster. This is a geogrid soil retained soil geogrid reinforced soil retaining wall around Kobe line. And 2005 there was a major earthquake, and after the earthquake you can see all the fragile houses collapse, but this retaining wall is still intact because it is reinforced with the geogrid. It is not concrete wall, it is just a soil wall. It is reinforced with geogrid. So simple reinforcement inclusion can do wonders. Well, coming to water security, India is a country of rivers. We have Ganga, Yamuna, Godavari, Narmada, Sindhu, Kaveri, so many rivers. We are highly blessed with rivers. And average annual precipitation is about 1176 millimeter, amounting to total volume of 4,000 kilometer cube of water, 4,000 billion cubic meter of water. And we have 6,000 large dams in the country, and the storage capacity for all these 6,000 dams put together is less than 350 BCM. Not even 10% water we are storing. That's why I say we are not running out of water, but water is running out of India. If you look at the global precipitation map, you will see India in blue or green color is highly blessed with rainfall. But same time, you see the water stress by country, India is in red or extreme red color. So this is a paradox. No, see, we are the country highly blessed with the rainfall, and we are the same country facing acute water shortage. Because we are not recharging our ground, water simply goes as runoff. If you look at the case of Bangalore, this is the topo sheet of 1960. There were more than 150 lakes. Now it reduced to 60. You will not believe, Kampakode Majestic bus stand was once a lake called Dharmabudi Lake. You can see Jalahalli East was Vidyaranyapura Lake. Matikere was Gokula Tank. Similarly, Rajrajinagar Industrial Area was Vadrapalaya Lake. Basveshwar Nagar, there was another lake. First terminal was Dharmabudi Lake. So you will see now lakes started disappearing, it reduced. That's why we are facing water stress. Every year we get the news. Even in region like Mangalore, where we receive close to 4,000 mm of rainfall, we are also having water shortage, even in our own campus. Now we are taking some steps to store water. So 54% of India faces high to extremely high water stress. And earth and water has very good relation. The first recipient of the precipitation is earth. Mother earth receives the water from rain. Then some of it goes as runoff, some gets evaporated, and some goes into the ground as groundwater. Earlier days we had no lot of space for water to go into the ground. Now we have paved our road, cut the trees. There is no time for water to go into the ground. So water goes as runoff, leading to floods during rainy season. So groundwater not recharged. So in summer we have drought. So we say India is not running out of water, but water is running out of India. If you look at hydraulic engineering in ancient India, we had a great bath of Mohenjo-daro from Indus Valley civilization itself. Kalane Dam, I talked about it. If you look at India's traditional water harvesting structure, this is from my own home pond. You can see rainy season and summer season, two pictures. Still, even in summer, we are able to irrigate our farmlands using this water. This is not used for drinking. This is used for irrigation and swimming also during rainy season. And we have open wells for drinking water. These are very common columns in Kerala. And in Tankas in Rajasthan, they have very less rain, so they store drinking water in Tankas. Ghadins, they make earthen bund to store water. Step wells, Jalaras, Bavadis in Gujarat and Rajasthan. This is also a place for gathering of common public. Kankaria Lake in Ahmedabad, SBI logo has come from this. Ahar Point system in Bihar, whenever there is a rain and flood, they divert the flood water through long canals called pines and finally it is stored in Ahar, a main lake. The Ahar Pine system, a flood advisory committee again recommended that a lot of flood because happening in Bihar because these Ahar Pine system were destroyed. So when this water passes through these long canals called pines, groundwater naturally gets recharged and finally water is stored in Ahar. So this Ahar Pine system is something that we need to implement. Bengal's inundation channels, Bhandaras in Maharashtra, Cheruvu in Andhra Pradesh, Kalyani's Karais in Karnataka, sinks to store melt snow water, Surangas, horizontal well. Even in my ancestral home also we had a Suranga, horizontal well. Through stable laterite we drill to the aquifer. It is very similar, connects in Arabian countries. Very pure water we get. And then we have modern structures like contour burns, pits and shaft, boulder checks, recharge well, water pools. Yeah, this is a case study I have done for Jharkhand Divyan Krishi Vigyan Kendra. That pond we have made. This is another case study from Uttarakashi. Then groundwater dams, it's another interesting water storage structure. We can have dam, underground dam. We can have dam underground and on top we can have houses, buildings, trees, everything. So surface water flow is arrested using a dike and you can extract the water. Underground dikes, subsurface dikes. Now, if we look at the global dam construction, we see after the year 2000, number of dam constructed is very less. Most of the dams constructed were during the period 1950 to 2000. Even in India, when we got independent, we had about 300 dams. Now we have 6,000. But after the year 2000, we are not building much more dams. So that is not a very good option. So I have a small video clip as an alternative solution. Yeah, please watch this. Yeah, so here we are introducing the concept of coastal reservoir. We have authored a book also. Now, happy to say now Tamil Nadu government has approached me. Karnataka government is also approaching us. They have shown interest in this concept. So Marina Barrage 2008 it started operation, and in 2010, 2008 it was completed. It's a 350-meter wide marina channel. It was a brackish water. They converted it into seep water. Tannirmukkam Bund. Actually, it was in 1970s. No, local people constructed. You can see Arabian Sea, and this is the largest lake in the state of Kerala, Vembanad Lake. Maybe it's second largest in the country after Chilka Lake. And normally, the seawater from Arabian Sea intrudes into the freshwater. So they constructed a barrage, TM barrage, and the fresh water that is coming from this Pamba Minachal river is stored in Vembanad Lake, and the seawater intrusion is prevented, so that they are doing paddy cultivation. That is maybe only one place where paddy cultivation happens below mean sea level. They are getting fresh water. So recently, we wrote an article appraising Tannirmukkam as a coastal reservoir. This is the bird eye view. And existing and proposed coastal reservoirs across the globe, you can see in India we have Tannirmukkam, and in Kalpasar project, Gulf of Kampat, Gujarat, it is proposed one. Actually, Kyun Kayosha reservoir, no, I have visited. It is in Shanghai. Actually, Yangtze River joins South China Ocean. In the estuary, they have constructed a beautiful coastal reservoir, and most of the water requirements of Shanghai city is met with from that. And also, we see even our water bodies also have problems with the collapse. And I will just present a case of Rangadittu Bird Sanctuary in Kaveri River. Actually, this is the only Ramsar site in the state of Karnataka. And we had a project actually, CWRDM, and I was the consultant. They have 20 bird species. It was actually a bund constructed in 1600s, 17th century by the king of Mysore. And with the silt deposit, islets, 25 islets formed, and he started attracting birds. 220 species of birds, migratory birds also come, crocodiles and water otters. Actually, when KRS dam water gets released, these islets pose a problem of stability. So what they are doing is these kinds of plastic bags, sandbags, polythene, and every 3 years they are replacing that. So that is causing environment, microplastics go into the water. So CWRDM proposed Kayar Geotextile. I was a third-party consultant. So you can see geotextile, cocoa logs, and here you can clearly see the difference when we are having sandbags that microplastics enter the water, and when we are having Kayar geotextile, you see even grass can grow. Even these sandbags they are replacing every 3 years. This Kayar geotextile also can be replaced in a similar way, but these sandbags when they are replacing means already almost these microplastics are going into the water, affecting the aquatic life and polluting the environment. But these Kayar they are biodegradable. They even facilitate the growth of the grass and plants vegetation. So this is one of the most sustainable options. So hope they will adopt the same technique to other islets as well. 9 islets we have tried. And coming to landslides or geohazards, can be classified into shallow geohazards like landslides, sinkholes, etc. Also earth hazards like volcanoes, earthquakes, tsunamis. When shallow geohazards include collapsible soil, compressible soil, soil piping also. This is a sinkhole, landslide in northeast, Kodagu landslide in 2018, Madikeri. 2011 earthquake, Sikkim earthquake triggered more than 1,000 landslides. Single earthquake triggered more than 1,000 landslides in the region. And very interesting report from GSI that 7 years data, 2015 to 22 says 59% of landslides in the country happen in the small state of Kerala. It's unbelievable, but it is possible because Kerala has Western Ghats and a very high amount of rainfall. And the landslide susceptibility map you can see on the right side. It is basically on the hilly regions, around the Himalayas and Western Ghats and Nilgiris. Here is the slope map of the country. You can see slope is very high along the Himalayas, north Himalaya, central Himalaya. Actually, Nepal region is not shown here. Here the political boundary is shown, so that is why it is not visible. Otherwise, northern Himalayas, central Himalayas, and northeastern Himalayas, very steep slope, and again along the Western Ghats. And landslides can be classified into fall, topple, slides, flows, etc. And coming to Western Ghats, yeah, it's a World Heritage Site and biodiversity hotspot and very highly vulnerable to landslide. Western Ghats covers 1,60,000 square kilometers, elevations ranging up to 2695 meters. Anamudi is the highest peak. And it acts as a barrier to southwest monsoon, leading to high rainfall in the windward side. So we enjoy that. And you can see the location of historical landslide in Western Ghats. It covers Kerala, Karnataka, Goa, Maharashtra. Only Palakkad gap is there. Otherwise, from South Kerala to it is continuous till Goa and goes to Maharashtra. But Palakkad there is a gap. And effect of landslide in Western Ghats: loss of human life, wildlife affected, loss of property, agricultural lands affected. And the causing factors we have seen, causing factors as mainly heavy rainfall, then soil properties, soil water interaction, and steep slopes, natural factors, and anthropogenic factors like road construction, building construction, disturbance to the natural slope through excavation, changing the natural drainage pattern. And here you can see the landslide density map also. A lot of landslide happening in Kerala along the Western Ghats. And we have the rainfall distribution map. You can see rainfall in some location. No, called Agumbe. Agumbe is the land of cobras, king cobras. It is also called as South Chirapunji. Now, Mysondrome is the highest rainfall receiving region, right? Yeah, if I remember correctly. Earlier it was Chirapunji. It is called South Chirapunji, Agumbe. So some regions receive as high as more than 5,000 mm of rainfall every year in the Western Ghats. So here is a case study: Wayanad landslide, the Mundakai Churalmala landslide of 30th July 2024. Lot of casualties. Debris flow extended to 7.8 kilometers, unbelievable. 200 buildings completely washed away with no remains. 400 buildings partially or fully damaged, unfit to live. Here are some of the pictures. You can see the crown of the landslide. It was a planar landslide through a weak zone, but it is the debris flow. It was unimaginable. 7.8 kilometers it has gone, blowing away everything on its path. Here is a small video of the crown. Some pictures. This is the close view of the crown. We have gone towards the crown. And here actually we have analyzed past landslide like 2018 Kuruchirmala landslide, then 2019 Kavalappara and Puttumala, two landslide happened. It was also very huge. Kavalappara was basically there was a human factor, but Puttumala, yeah, it happened in the hill forest area. Then 2024 Mundakai landslides. Actually, there was a prolonged heavy rainfall. You can see 2 days, 29th and 30th. Total rainfall is 572 mm. 630 mm in a year, but in a just this 48 hours span, 572 mm of rainfall. It is the historical landslide points in Wayanad. Here you can see the difference. It is available on the web before landslide and after landslide. You can see. In 2020 there was a landslide, but the debris flow stopped at Bundakai. But this time it was huge, huge, huge. Some places the stream has widened, no, which was 30 meter, it has become more than 150 meter, like that, taking away everything on its path. See, it was a huge disaster. You can see the difference. Top was before, and then on bottom it is the after landslide. Close to 600 buildings affected. So actually, we have modeled that, collected soil samples, tested them. We published a paper also in Landslides Journal of the International Consortium of Landslides. Yeah, if there is time, I can show in Google Earth also, maybe some other occasion. It originated at about 1565 elevation, and we have done the debris flow modeling. You can see in the bottom right, the debris flow modeling with the flow height. We saw that even debris flow has gone up to a height of 67 meters. It is so massive, huge. So this actually poses a question to ourselves, whether it was a natural hazard or a man-made disaster. It was a natural hazard. Landslide happened in the forest area where there was not even plantation. Human settlement happens after 1 kilometer, 1.5 kilometer from Fujimatam only. But the disaster, it became a disaster because of the exposure. Because we have seen from Punjinamattam onwards, the human settlement starts, and many of the constructions, especially in Mundakai region, Churamala region, in the floodplains or the stream bed itself. And it affected 4 towns or villages, no? Punjinamattam, Mundakai, Churamala, and Attamala. Another case study, Shirur landslide, yeah, it was human made actually. Yeah, heavy rainfall was there, but they have made a cut excavation for highway expansion, and the soil debris went up to the Gagavali river, even up more than 100 meters. Such huge disaster. Again, heavy rainfall was there, prolonged rainfall was there. Again, Kodagu also we did a study, there was massive landslide. And when we found from these studies that most of the contributing factors, if we consider like slope, aspect, distance from land, soil parameters, elevation, land use, vegetation, transportation network, rainfall, surface flow, soil moisture, we found the drainage density is the one that contributes the most towards the landslide. So, landslide in Western Ghats come from natural as well as human-induced factors. Intense rainfall is the main cause, and unchecked human activities like unscientific excavation causes actual removal of. If you remove the top of a hill will get destabilized. So sustainable mitigation measures should be there, and landslide early warning system also. So I will present some on how we study landslide. Using GIS data, we can do micro scale or macro scale study to prepare landslide susceptibility map and to identify critical zones. If you have meteorological data and geotechnical data, we can actually develop early warning also. We can do experimental investigation, numerical studies, threshold we can find. Actually, we have made an attempt for developing that early warning system. Here is an exposure of population to landslide for the state of Kerala that we have done as an academic exercise. And we have developed a landslide early warning system indigenously. We have a national facility at NITK. It works based on 3 principles, 3 level warning. Number 1, rainfall threshold. Number 2, pore pressure. Number 3, surface deformation. Maybe I will show you some. Yeah. This is the working principle. We get a message. Actually, when rainfall threshold is crossed, message goes to the administrators. When surface deformation happens, it can go to the public for evacuation. This is the basic principle and parameters that we consider. We have a landslide flow at NITK, and we have fundamental soil mechanics principle. We have a small as well as a large tilting flume. Here is a one demonstration of the study that we have done. You can see a translational failure happened, but before failure, this runs for several hours. We have fast forwarded. We can see much before failure, this erosion happens, and nature gives indication. Even the ADGP Vijay Kumar in Wayanad landslide, they also told previously there were a lot of indications given by the nature. Here you can see the surface deformation, the point A moved to B, and still slide has not happened. Slide happened even after several hours after this deformation. So we can get a 7 to 8 hours advance warning most of the time if we closely look. It is difficult for us to sit and watch physically. That is why we insert sensors. They will give us the data, real-time data. Also, we need to have some Doppler radars to identify cloud burst. Because IMD data, no, that gives a very general data. And we know advocates always look who is wrong, who is to be blamed. But as engineers, we look at what is wrong and how to fix it. So we need a sustainable engineering approach. So geosynthetics is very popular inclusion, soil reinforcement technique, which can be used for slope stabilization. Different types are the geogrid, geomembrane, geonet, geotextile, geocells. I will go a little faster. I'll try to conclude early. A lot of applications. These are very common along the highways. You know, this day you are seeing they are all geogrid reinforcers, soil retaining wall, just simply soil. A lot of advantages. Raw materials are basically polymers, but everything about geosynthetic is good. No, that will go into the earth. No, if we bury them. So that is why we propose geonaturals, Kayar, Araka, Sisal. Because long-term use of geotextiles, ultraviolet, etc., it will cause disintegration of synthetic polymer, resulting in microplastics. So that is why sustainability is important. So we recommend natural geotextiles, which can be applied for almost all infrastructure applications like road construction, embankment, PVDs, erosion controls, road protection, etc., and whatnot. All basic functions of separation, filtration, drainage, reinforcement can be taken care. Here is an example. Say you can see on the left side a road section without a geotextile layer, and on the right side road section with the geotextile layer. So it is preventing the intermixing of layers, and see potholes are prevented, arrested. Global geotextile market, mostly used in road construction, followed by erosion prevention. Here from Kabalapara landslide, there was an interesting observation. So many houses got buried, unfortunately. But 7 to 8 houses got saved because of this vegetation cover. And we know tree roots acts as a good reinforcement. And plants like vetivers can go as deep beyond the failure surface also. We did some experiments, reinforced the soil with different natural fibers and synthetic fibers, and we found when we reinforced the soil with the Kayar fiber, unconfined compressive strength increased almost 150, say almost more than 50%. PVA gave some improvement, but Araka Sisal Kayar gave extensive improvement, and optimum quantity was 1.5% by weight. Here is the soil fiber interaction. I have shown this. We can even have soil savers like this. This was installed in Baitur. Soil geocells, Kayar geocells. Actually, Araka leaf should be patented using Arakana trees leaf sheath. We made a geocell and geogrid, and I have patented it. We also made out of Kayar, jute, Sisal, and even Sisal geocell retaining walls also we experimented. Kayar geocell retaining wall. Under dry condition, HDPE was working good, but under wet condition, Kayar was giving better performance. And some model footing test. Here I will show you one small experiment that we have done. This is an unreinforced slope. This 3 hours video, cut short into less than a minute. And rainfall we have simulated 200 mm per hour rainfall. You can see the failure pattern. The same slope, same rainfall intensity, we reinforce it with Kayar geocell. And yeah, this is after every 30 minutes now, unreinforced slope, how it looked like. And with the Kayar geocell, you can see the video. After every half an hour, you see failure has not happened. Actually, in the Kayar geocell pocket, some deformation is happening, but there is no failure happening, and erosion is also very less. I will show the video at the same time. This is the tilting tank which we used. Yeah, you can see both at the same time. Left side unreinforced and right side it is the Kayar geocell reinforced slope. You see unreinforced already started forming gully erosions, gullies. You will see the failure happening in the unreinforced slope. But Kayar geocell reinforced, it has not yet failed. So that is the wonder reinforcement can do. And jute geocell, yeah, this is my patented product. We developed in association with the Birla Jute Mills. Birla Corporation, it is more than 100 years old company organization. And the beauty is we are mechanically stitching this, so the cost has come down. The natural Kayar geocell, no, when stitched with the hand, it costs more than 1,000 rupees per square meter. But now this jute geocell will come in just 135 rupees because it is mechanically stitched. And mass manufacturing capacity is there. So this is the mechanism of geocell. Normally, when we apply load, failure surface is developed like this. But when we have geocell inclusion, because of the lateral resistance effect, shear resistance, then membrane effect, etc., and vertical dispersion, we get the bearing capacity, 4 to 5 fold increase in bearing capacity. So we have tested all different materials. So I will not go into much of the details. I will try to conclude slowly. Even coconut shell also, we have patented. We have done some studies. I just quickly go through. So we compared the performance of coconut shell reinforced soil with HDP geocell reinforced soil. We found a very, very good improvement. With the coconut shell, it is giving much, much better performance than HDP geocell. We have done same for sand as well as clay soil. Published a couple of papers and analytically modeled also. Again, Kayar geocell also we did model footing test. This is the jute geocell project that I am handling. So a lot of iteration we did, trial and error. First we found it was breaking at the joint, then we strengthened the joint. 2-ply yarn was used first, then 3-ply yarn, and a lot of works are going on landslide studies, etc. The jute, actually, the beauty is 85% of jute production happens in Bengal Delta, and absorption of CO2 is very high, and emission of O2 is very high. So, and it has wide variety of applications in roads, railways, and it is our own product actually. It has to be promoted. These are some of the case studies of installation of jute geotextiles. You can see the road condition before laying JGTC, how soft it was after laying JGTC. Even after 2 monsoon season, it is intact. We can use JGT for riverbank protection. JGT means jute geotextile. Even in railway also we can use wide variety of applications. Yeah, in 2020 there were a lot of collapse that happened close to NH66 in Mangalore. Then the corporation authorities came to me and we proposed them a hybrid design actually. A combination of soil laning, it is called shored retain protection wall because we cannot stop the traffic even for a minute. So we suggested soil laning to reinforce the existing road section, then additional geocell retaining wall for expansion. Another case study where we proposed geocell retaining wall to retain the soil and Kayar geotextile and soil laning is All India Radio Madikeri. We proposed geogrid inclusion to reduce the earth pressure. Again, there at other location we proposed geocells, and again in KPTCL, the tower line, we proposed geocell retaining wall. At some location we proposed the gabion walls. So it has to be site specific. In this case, it happened in Ulla. We saw that one retaining wall they have constructed and it has collapsed. But you see, the wall is very intact. Actually, I said if the wall was not constructed, the failure would not have happened. Actually, there was no beep hole provided. There was no base width provided sufficiently. So that is a simply collapse. Actually, we have to feel the earth. We should give way for water to flow. So this is again ISPR HB pipeline exposed. Like another failure that happened in Mangalore smart city. Yeah, this I have shown. Again, Indian Naval Academy, I am the consultant for landslide mitigation. It is in a hill actually. So there we propose several techniques, including rock netting, geotextile layer, rock anchoring, again geocell wall, vibration absorber, rockfall barriers, etc. Again, this is another case study from ISPRL, Indian Strategic Petroleum Reserve Limited. So only we have 3 caverns in India: Padur, Vaishag, and Mangalore. Vaishag cavern takes care of entire northeast and West Bengal. Padur entire North India, and this Mangalore, from Mangalore, it is South India. It is strategically located much away from the border. It is underground cavern. Here we cannot take any risk actually. Even if oil supply is stopped from foreign countries, we can run entire country for 1 month from the oil stored here. Nobody, even Mangalore people don't know about it. So there was a slide happened. We cannot take a risk. So we propose a gabion wall. It is completely finished. Gabion wall with the proper drainage and vetiver plantation. This is another geocell retaining wall we propose for a tourist home in Munnar. Again, it is in Western Ghats. This is another bank protection we propose for Netravati River region. And this is Ukai Dam, that is second largest reservoir in the state of Gujarat after Sardar Sarovar Dam. So I am the consultant. We are taking the dynamic stability analysis. Yeah, for more details, you can refer to my books. So I will make a one-line conclusion. Ecosystem-based disaster risk reduction is the way for sustainable development. So Mother Nature has already shown us the way. We should feel for the nature, respect the nature, then do our engineering based on our intelligence. But make sure that our technique is aligned with nature. Thank you. My acknowledgement to all the funding agencies, students, collaborators. Thank you. Yeah. And welcome to NIDK. Maybe only one campus in the country where we have our own beach. So welcome to visit NIDK, 300-acre green, lush green campus. I'm sure you will enjoy our campus. So whenever you are coming to this part of the country, make a point to visit NIDK. You can also, actually recently